Ladies and gentlemen, good afternoon. My name is Kevin Wood. I work for Cybermore Services. We are one of the partners on the project, and our responsibility is the management and coordination. Cybermore is a community enterprise based in Alston in Cumbria, and for more than 20 years we have been working to deliver high-speed connectivity to rural communities. Obviously 20 years ago, high speed meant something different to what it means today. A few words about where we are, an update on the project. It's DCMS funded under their Rural Connected Communities scheme, DCMS, Department for Digital Culture, Media and Sport. They funded 16 such projects under this program. Ours is a 25-month project, it's 10 months in. We have a budget of £6.4 million, of which £2 million is provided from the commercial partners, so it's not fully funded. The partners you can see in the logos below. The outcome is quite simple, to try to build a network into Coverdale to deliver ultra-fast connectivity. At the end of the project, the network will stay in place and will be run by Quickline, who are the lead partner, on a commercial basis. The aim is simple, to eliminate the digital divide, to overcome this vast discrepancy that exists between the haves and the have-nots in terms of connectivity, mobile broadband, etc. There is a research element to this project because we are using the latest wireless technology to deliver this so-called ultra-fast connectivity. And ultra-fast means sort of up to 1 gigabit a second. That's the same speed as you'd get over fiber to the premises. The difference is it's so much cheaper to put it in that in a rural area where it's sparsely populated, the same budget goes a lot further. Some of you may be aware that there is an application in by Openreach or BT to deliver fiber to the premises to another community. To reduce the cost, they're using it strung across poles rather than digging it into the ground. Their request is for 11 poles to cover an area which we plan to cover with just one single mast. There are a lot of practical problems. There's the environment, there's the trees, there's buildings, etc., and not the least the terrain. So we don't exactly know how far we can go, and as the project evolves, we will attempt to expand those areas. The service which we will deliver is broadband and what's called data telephony. And that means the likes of WhatsApp, FaceTime, Zoom, Wi-Fi calling, etc. And all of that will be delivered via a router that will sit in one of the rooms in your house, exactly the same as if you'd bought a conventional service from somebody like BT. To enable that service to work outside of the premises as well as inside, we are intending to use what's called a MiFi, which is a mobile router, and this is one that is supplied by BT. You can see an idea of the size and the thickness. It doesn't weigh very much. It can easily go in your pocket, your handbag, etc., and it gives you the same service outside the building as it does inside. Until everybody gets a 5G phone, or until most people upgrade to a 5G phone, and such a 5G phone would replace the need for the MiFi potentially, we are also going to develop a trial within Coverdale to see if we can connect conventional sort of 3 and 4G phones to this new service. So where are we so far? Well, we've had a number of meetings with various councillors, parish councillors and residents, and as Leah said at the beginning, except for right at the very beginning of the project, they've all been online. Having been involved with lots of these projects over the years, I share Leah's view. I would rather we were in a face-to-face village hall environment, but that's not allowed, that's not permitted, so therefore we're doing it in the form we have at the moment. But so far we have gained support for the project from the majority of the parish councils. As well as testing the technology, we are also carrying out a review of how people use that technology, what they both would expect to use and what they actually use once it gets installed. And all of that program is being carried out by Lancaster University, and one of my colleagues from Lancaster will speak in a few minutes about that. We obviously have a challenge apart from the fact somebody's drilling in a wall up above me, and that's COVID. We know that we've been slowed slightly, slowed because people are off with the virus or having to self-isolate, and slowed because the materials which are coming from various places around the world are being delayed by the same thing. But nevertheless, funds have been committed and continue to be committed. Both government and partners are sticking to their budgets. And as I've said, once the project is complete, once the network's been built, it will stay in place and be run by Quicklime. The fact that this project is going ahead despite the virus and various other challenges is a plus, because as some of you may have seen, there's a parliamentary report on the 8th of January that says the rollout of ultra-fast broadband across the country is way behind the government's targets, and it could well be several years before they deliver what they originally intended to do by 2025. Coverage, this is the area that we're going to cover. I don't claim to know it well, so if you have particular questions, please ask them, put them in the chat box, ask the questions, and one of the North Yorkshire people will respond. 2 red dots are the masts that we propose to put up, and the photo you can see is what a mast will look like. It's not a massive metal structure, it's a simple telegraph pole with some radio equipment on the top. You can see a fence around the bottom of the mast. Again, that is not some screen for radiation, it's a mechanical protection so that when the farmer is in the field, if he's using a tractor, he doesn't actually drive into the mast and damage it. Benefits. Yes, we are pushing technology, but we are not using what you might call in some way dangerous technology. It's standard radio equipment. It's exactly the same as what's been used for 4G. We're using the same wave bands. The difference is that the way in which the wave bands are managed, and a colleague will talk about that in a minute, it is managed by software. It uses a lot less power, so therefore it is has a lot less intrusion on the environment, uses a lot less power. The important thing is that we want to build a 5G network and not a 4G network. 4G was introduced in 2012, so it's nearly 10 years old, and it's yesterday's technology. In another 8 to 10 years, we'll be talking about 6G, so it will be another upgrade. But what we're trying to do is to make your community as future-proof as we can. The sorts of benefits we're looking at are mobile diagnostics, so that you'd be able to connect to a hospital or a GP practice. And in these times, that's obviously relevant because the hospitals and the GPs are relatively closed. And in a rural area, and I spent many years living in a rural area, we only had 1 bus in the morning and 1 in the afternoon. So if that was the way you had to get into town to see your GP, you had to waste an entire day. So a change in your use. We will extend the capability to upgrade the services for ambulances. So it means that when an ambulance arrives at a patient's door, they're able to commence analysis and treatment, even connect to a hospital consultant, even through the use of virtual reality headsets. So we will all have heard of this idea that the first 60 minutes after an incident is the most important. What we're suggesting is the 60 minutes begin when the ambulance arrives at the patient's door and not when the ambulance gets the patient to the hospital. We will extend that same concept to mountain rescue, putting equipment in the back of Land Rovers so that the facilities and resources that's available to the team on the mountain is enhanced compared to what they can do now. And obviously that will include the use of state-of-the-art drones so that the search process is quicker and more information can be fed back. Virtual schooling, online, at the moment, homeschooling, I should say. Everybody is familiar with this idea, even if you haven't got children at home at the moment. Those of you who have no connectivity will be fully aware of the limits that your children can undertake with homeschooling. The service we're going to put in is not merely going to bring them up to the level which will give them access to the school's online learning systems, but through the sorts of sites that are being developed around the world, they can even take part in the likes of virtual reality schooling. Support for the community. Monitoring of floods, maybe bridges are out. I understand in your area that you have a water service which is provided via a voluntary group. It's our plan that these control centres would be able to connect remotely for either monitoring or for adjustment, which means that in heavy snow, a volunteer doesn't have to trudge up the hills to get there and carry out the work. And finally, business. Obviously, where there is connectivity, small businesses, large businesses will be growing up. But in an area where there is no connectivity, and the two main businesses are farming and equestrian, farming today is an online business, whether it's subsidy claiming, reports, sending records of milk yields or machinery usage, etc. And in an arable production area, you've got precision farming, which means that the farmer can accurately manage water, chemicals, fertilizer. It reduces their costs, it increases their yields. It's a significant benefit to the farmers. I don't claim to know anything much about equestrian, but I did look online and there's some fantastic tools that's available to help manage the training and the business itself. Again, you have stables that have no connectivity, they can't access these tools. And finally, the personnel. Obviously, both farming and equestrian has individuals or small groups of people that are miles away from anybody else. In the event of a problem or an accident, they need to be able to connect to colleagues, emergency services, whatever. And obviously extending that into the mental health issues of farming, the loneliness, the isolation. If you were a tractor driver sitting in your cab, chugging up and down the field in a semi-automated environment, how much better would it be for you if you could connect to friends and family or communicate with the farmer or suppliers or somebody, or even undertake some upgrade or training whilst just sitting in the cab? So with that, I'll say thank you and I'll pass across to my colleague, Katie Mason.
Hello everybody, I'm Katie Mason from Lancaster University, and my next slide talks a little bit about the role that Lancaster University has in this project. So we're probably all recognised, and most of us accept, that connectivity is essential for our everyday lives. We've already heard examples from Kevin about how it intervenes in our working lives, education, but also everyday family life, and we keep in touch with relatives and friends. Many recognises that different people within any community have different experiences, hopes and concerns, and even questions about any new connectivity services that this project might offer. And so our role as Lancaster University is to act as an independent group, but to look at the Coverdale communities and to lead a programme of interviews with residents and local businesses to try and understand what those experiences, hopes and concerns or questions are. There's also a technical team from Lancaster University, similarly working in an independent way, and they're monitoring and evaluating the technical equipment. So as the technical equipment becomes installed as the project progresses, they'll be monitoring that to check that it is delivering on the quality of connectivity that we are hoping for. So to my part of the project, which is to look at what people feel, experience, and the questions they have. So far, we've done just over 20 interviews. We want to do more. We're hoping to get it up to about 50. So if you'd like to be part of this project, please do contact us. What we're doing is we're doing these interviews that typically last about an hour, and then we code the data looking for patterns across the data that show common experiences and common hopes. And we're analysing those into themes, and then we'll ask the many technical team to look for solutions to these specific common experiences of, we'll see what some of those are in a minute, and the hopes that these solutions might create. The other really important part of this work is to listen to people's problems and questions. And when we're sharing these with the technical team, we're asking them to explain, provide answers, and try and overcome the concerns. So what are the patterns we're seeing around the experiences? Lots of people are telling us about poor connectivity and time wasted when connections drop out and they're trying to do something for work or for their business. And you can see some quotes here that illustrate some of those problems. And they generally tell us that these poor connectivity makes life really difficult for them. On the next slide, we look at the hopes. And these hopes we're hearing about are about what connectivity could offer them. So they're looking for a reliable service, and they're also looking for mobile connectivity. So some people are telling us that they have some connectivity in the home, and this is really important for home workers. But also if you're a farmer, you need that connectivity to reach out into your landscape and the broader area of work. We're also hearing that connectivity actually, many people think it has the option to attract people to the area or to keep people in a community. So we know a lot of what happens in rural communities is this notion of what we call hollowing out, where young people feel there's no work for them, they can't work from home, and as much as they might love their community, they end up going away to find work because there isn't enough business generated in the area, because that connectivity is now preventing business. Other people are also talking about the idea of what the future is bringing. So we recognize that software packages are being improved all the time. They take up more and more energy and data and space. And so there's this notion of future proofing, which is setting up a digital infrastructure that can absolutely be ready for the future as the technology changes, as the software grows and is able to do more things and takes up more data space, then the infrastructure is there to support it. And what we see a lot in rural communities is that infrastructure gets put in and then it's left, and it doesn't keep pace with the change that you might see in the connectivity offered to cities. So in the next slide, just to sum up about the hopes. So people are talking about, sorry, it's not hopes, it's questions and concerns on the final slide. People are talking about their lack of understanding of 5G. 5G is an all-embracing term. It just stands for the 5th generation of technologies. So it means lots of different things. And lots of people are telling us they're very confused about this and that they want more information, not just on 5G generally, but also 5G specifically for this project. They're also telling us that they have concerns about the aesthetics of the countryside. People were unsure about what the equipment would actually look like, how intrusive it would be, how obvious it would be. And so that look of the countryside, especially with the North Yorkshire Dales being a national park, is very important to people. And also people are concerned about this sort of technology and this sort of connectivity specifically actually changing a community way of life. Many people were telling us that they feel that there's a real sense of community cohesion and that really matters to them. And some people were telling us that they're concerned that digital connectivity will lead to an eyes down community. So everybody's there looking at their phones instead of looking up and communicating and speaking when they have community events. And we certainly have seen that in cities. So maybe there's some grounds for those concerns. But this is what people are telling us so far. There may be other issues that are relevant to you that you think we should know about. So please do email us and put yourself forward for interview. We can tell you much more detail then about how the interviews are run and how we use your data, and how we also protect your anonymity when we're using your data to try and inform the project so the project works well for this community. So that's all I want to say for now for the community part of this project. I'm going to pass you over to David, who's going to talk to you from the University of York about the technical and technology used for the Many project.
Okay, thanks very much, Katie and Kevin. So I'm David Grace. I'm from the Department of Electronic Engineering at the University of York. I also lead the Communication Technologies Research Group there, and I've been looking at wireless communications really now for getting on for 30 years. And on a personal level, I live in the North York Moors National Park. I live in a rural village of about 100 residents, and that village currently doesn't have any mobile signal on any network. So I'm very familiar with the difficulties of working and living when you have very limited connectivity on the mobile signal. So I'll talk today about the technology. So if we can have the next slide, please. So there's been a lot, as been mentioned earlier on today, 5G is quite emotive, but is actually only really the 5th generation of mobile technology that's been deployed. And it's actually very similar to 4G. Parts of Swaledale, Wensleydale have been using similar technology for the last 14 years. But it is an upgrade, and the upgrade is mainly in the software and the networking side of the technology. Software replaces hardware, it cuts costs, and that means that 5G is available for rural areas when in the past nothing has been available. The main benefit is that it increases speed. 5G is 50 times faster for the user than 4G technology. And it allows for new applications, particularly Internet of Things applications. You may have seen smart doorbells, smart applications for managing your livestock, for example, if you're a farmer. And the software also allows for remote management and upgrade of the network. That means that you can get upgrades to the technology faster. The technology itself is licensed and used worldwide. The main regulator, of course, in the UK is Ofcom. And Ofcom takes safety very, very critically. And the power levels with 5G remain very low. Ofcom has produced a 5G guide, and recently in that guide they talk about measurements they've made at mobile phone mast sites, and they said that the maximum measured at any mobile site was approximately 1.5% of safety guideline levels, and that includes signals from other technologies. And to sort of put the power levels in context, the power level from a mobile signal is actually very similar in terms of exposure in a home to what you experience in your Wi-Fi router. So it's very, very low power levels. Next slide. So if we delve a little bit more deep in a little bit more detail about the actual transmissions, because again, that's been quite controversial. Are 5G transmissions different to 4G? Well, not really. The 5G spectrum has been used for many years for other applications. For example, TV broadcast, military, and point-to-point microwave. The chart on the right is from Ofcom again, and that looks at the radio spectrum. And the blue verticals there are the bands that have been set aside for 5G. And the bands of interest in Coverdale are really sandwiched between the 2.4 gigahertz Wi-Fi and the 5 gigahertz Wi-Fi bands. Wi-Fi, of course, is what you use in your router at home. Both of those frequencies are used. So it's right in the middle of that. You can also see the 2G, the 3G, the 4G bands, and they're all around that particular part of the spectrum. Microwave ovens operate at 2.4 gigahertz. So we're looking at very tried and tested parts of the spectrum. The other part of the spectrum, the visible light, the ultraviolet, the X-rays, the gamma rays, is way up in frequency and operates in a completely different way, really, to what you see for the spectrum that's used for radio communications. Spectrum is already used for 5G in the UK in these bands. It's not, Coverdale is not a pioneer in that respect. 5G uses what is known as OFDM, orthogonal frequency division multiplex. You don't need to know about the detail of that, but it's 4G and the same. So nothing particularly different there. 5G also uses beamforming, although it's not going to use beamforming Coverdale. Beamforming just means that you can better signal where you want it and therefore minimize the exposure of that signal to other people and other places. It's a benefit, not a drawback. Back to the Ofcom 5G guide again, looking specifically at the 5G signals. The highest power level from 5G signals specifically was 0.039% of the maximum set out in the safety guidelines. So very, very, very low power. I do want to emphasize that. And it's not any more of a threat than any of the other signals that we're very used to today. Thank you.